Our fourth sense is auditory, and auditory includes your sense of what? Hearing and balance. So right here, it's on page 6 of your nervous system notes, a brief overview. And then there's an official picture of the ear on your official picture sheet for the nervous system and senses right here on the bottom. And so look at that picture and learn those parts. And then in your lab pack on page 50 and 51, there's a list of all the organs that we're gonna are associated with the brain, and then with the eyeball, and then the ear right here. And then it also can give a brief description of what it does. So you might want to look at that page 50 and 51 in the lab pack. Now on the board, we're going to go through this, the auditory sense. And so here it is. What's the organ associated with your sense of hearing and balance? The ear. And basically, for hearing, all parts of the ear are involved in hearing, and only the inner ear is involved in balance, okay? So for hearing, outer, middle, and inner ear, and over here in my drawing, I color-coded it, okay? Everything in brown, which is covered with thin skin, this is the outer ear, okay? Then the red part, the red structures, the organs here and here, this is gonna be middle ear, right up here, okay, middle ear. And then everything in green back here is gonna be way up there, inner ear structures, okay, / organs. All right, so going back here, where is your sense of balance interpreted and stored? Why, that would be your inner ear. And so inner ear only, hearing for all 3 areas. What is the nerve that controls your sense of hearing and balance? It's called the auditory nerve or the vestibulocochlear nerve, okay? And then where is it interpreted and stored? In the temporal lobe of the cerebrum. So right above your ear, right here, is gonna be the temporal lobe on right and left sides of the cerebrum. All right, so now let's go through the ear and the sense of hearing and balance. And so first we're going to talk about the outer ear, okay, the outer ear here, and it's all covered in this brown tissue, which is stratified squamous ET, thin skin, right? And underneath it, giving your outer ear and holding its shape and structure, is cartilage. And so this area of your ear, the large area right here, it's called the pinna. That's how you pronounce that, the pinna. Another name for it is auricle, which means your whole ear lobe right here. But we don't like auricle because it's used with the heart. So ear pinna is the whole ear lobe right here. And then where you usually put your earrings down here, that's a lobule, because it's got a different type of cartilage underneath the skin, giving it support and its stretch. So out here with the pinna, we have the dark blue cartilage, and that's going to be hyaline cartilage, CT, that gives it shape and makes it stiffer. And then the elastic cartilage is underneath your skin here and very easy to pierce because it's elastic cartilage, CT. So when you pierce the pinna, it crunches because hyaline cartilage, CT, has more collagen fibers in it that will give it that sound once you pierce it. All right, so the helix right here goes around the edge. And so you'll notice that the edge of your pinna, the skin and the cartilage folds over. And this is called the helix. The helix is that outside edge on your earlobe right here. All right, and then the next part is called this tube. So if you stick your finger in your ear, you're going down the external auditory canal right here. And so it is covered with thin skin. It's got hyaline cartilage underneath it to keep it open. And then the last structure associated with the outer ear is the tympanic membrane right here, the tympanic membrane, which is also called, common name, your eardrum. So that will never go into medical records, only tympanic membrane, right? Because tympanic means like a drum in an orchestra or a band, the timpani, right? All right, so anyway, so now what does this area do? What does your earlobe actually do for you? Well, what it's going to do is collect sound waves. And so the sound waves are all going to come in here, and they're going to be like, it's going to be like a megaphone. And so it's going to try to collect all the sound waves. So collect sound waves is what this outer ear does for you. And it's going to shunt them down into this little canal. Make the sound waves go down, keep going down to the tympanic membrane. And so that's what the auditory canal does, is it just moves the sound waves down to your tympanic membrane. And then your tympanic membrane is going to vibrate. It's going to vibrate like this, really, really big, and vibrate. And it's going to hit this bone right behind it. It hits the bone right behind it when it vibrates. So tympanic membrane vibrates. That's its function. And so those are the functions for the three big structures associated with the external or outer ear. So again, the pinna collects sound waves. The auditory canal, external auditory canal, moves the sound waves down to your tympanic membrane, and then this is going to vibrate so it can transfer the sound waves to the next bone, to a bone in the middle ear. All right, now a little bit more about the external auditory canal right here. It has glands in the skin, and so these are ET glands made out of simple QBT, and they're called ceruminous glands, okay? Ceruminous glands, they make wax. And so the wax will come out of the duct and go down the canal, and it goes down to the tympanic membrane. And so what's the wax purpose? Well, it has enzymes in it to destroy bacteria. So it actually protects your ear canal from getting infections. And then the wax also goes down here and lubricates the tympanic membrane to keep it flexible so that it can vibrate and not get dried out and very stiff. And so that would be the function for wax. And wax is actually a form of sweat. It's actually a kind of sweat, and so it has a pH of 5, just like our normal eccrine glands has a pH of 5. All right, so that's everything associated with the outer ear, okay? Now we're going to the middle ear. The middle ear right here. Oh, one more thing. The tympanic membrane right here. What's it made out of? It's made out of stratified squamous ET, and it's made out of specifically the stratum corneum, the dead layer of cells, and stratum granulosum, and a layer of loose ET. Right, loose ET fen with little capillaries in it to feed it, to keep it alive, because we know stratum corneum is a dead layer of skin. So it's not made out of all 4 layers of the epidermis, but just 2, and then loose ET fen. All right, so once your tympanic membrane vibrates, now we're in the middle ear, and we have 3 small bones. These are the smallest bones in the human body, and they're collectively called the auditory ossicles. Auditory ossicles means bones associated with hearing. They're the 3 smallest bones in the human body. So the first one looks like a hammer, a bad hammer, and it's called the malleus. The malleus, common name, hammer bone. And then the second one is sort of cup-shaped and goes down, and it's called the incus bone, okay? The incus, the anvil is its common name. Then we have a sideways stapes, bone stapes, common name, stirrup, like on a saddle, sideways. And so those are the 3 middle ear bones, M-I-S. That's how they go. And what do? They vibrate. They vibrate, and so these are going to vibrate. So once the malleus bone starts vibrating, then the incus bone picks up the vibration, and then the stapes will start vibrating, and here it is. And so it conducts the vibrations through the middle ear. That's its function right there. Now the middle ear bone, okay, this is like temporal bone, you have pseudostratified columnar ET cells with goblets. And so that's what this lime green layer is in here. And so it's all aligned with pseudostratified columnar ET with goblets. And that's why you can have middle ear infections, because these pseudostratifieds go down a tube right here. It's called the eustachian tube, also called the auditory tube, and also called the pharyngeotympanic tube. All right, that's a lot of tube names. So what do the doctors use the most? Eustachian tube. And so technically the mucus should drain down this tube into your throat, into the nasopharynx. And why do you have this tube associated with the middle ear? Because air can come up it from your mouth. It can actually go up it. And so every time you swallow, this tube sort of like spreads out the air in here. It equalizes the air pressure so that your ears don't pop. So when your ears pop, that means you've got a lot of plugged mucus in this tube, and the air, every time you swallow, is making the mucus pop so that the air can get through, because it wants to clear out the mucus in the inside of there. All right, so that's the eustachian tube, but that has nothing to do with hearing or balance, no. And so, yes, if it's clogged with a lot of mucus, you may not hear so well, but then the mucus is also going to be in here around these bones. And if you have mucus around these bones, they can't vibrate as well, so you're not going to hear as well, right? Your hearing will be more muted. All right, so that's the functions for the middle ear right there. Now we go on to the inner ear. The inner ear, and the inner ear has 3 sets of bones, all right? So here's the vestibule. Here's the first bone. And so it's a big round one right here. And all of these bones have simple cube ET in them, okay? And they're going to be making a liquid that will go back and forth inside these bones only. So the first bone is the vestibule right here. And then we have 3 that look like semicircles. And these are called semicircular canals. And so they're little thin bones. There's a lateral one, semicircular canal. There's an anterior one, and there's a big posterior one. And so they're named for their location. And so nice and thin, and they sit on top. And then we have one that looks like a snail shell, and it's called the cochlea bone, cochlea. And so all of these have the simple cube in them. I drew that in there. And what do they do? Well, they're going to make a fluid. And so the fluid is called perilymph, and it's high in water and salts, sodium electrolytes essentially. Sodium, potassium, chloride, glucose, and protein. And it's got a neutral pH of about 7 to 7.4. And so what does it do? It's going to help with your balance, okay? And I'll show you that in a minute. And then as you age, the perilymph gets thicker. So when you get in your 60s, it's going to get a lot thicker, and you're going to have calcium stones develop in it. And this is why a lot of older people have trouble with balance, because the endolymph is not as much water, it's thicker, and it's got stones in it, and then the stones can get stuck and basically throw you off balance, right? So I'll show you how this works right now. Now, so those are the three sets of bones associated with the inner ear and what they make. So perilymph is the liquid inside here until about age 60. Then it gets thick. All right, now we've got to have the auditory nerve, okay? The auditory nerve. So here's the auditory nerve, and it's coming into the temporal lobe, and so it's number 8. And so it's going to come down here, and then it branches. It gives out branches. And so branches go to each semicircular canal. So I've got one on each one right here. It's going to go to each one of these, all right? And then you've got to have a branch that's going to go here on the snail shell, right here, okay? And then you got to send out branches to the vestibule, right here. The vestibule bone or vestibular bone. And so that's where the nerve branches and gives off those areas. So what do we call this area where the nerve stops and then gives off the branches, all these dendrites that are going to go off? It's called the spiral organ, okay? This area is called the spiral organ, or another name for it is organ of Corti, okay? Organ of Corti. Spiral organ is more accepted right there. And it's a high area of dendrites. Dendrites. So why do we need dendrites? Because dendrites need to pick up the vibrations of these bones. And so if it's for hearing, you've got to pick up the vibrations. So these are dendrites sitting on top of these bones, sitting on top of the bones, and they're detecting vibration, okay? Vibration of these bones for hearing. So these bones vibrate, then they make these bones vibrate, and when these bones vibrate, then this is going to create electricity, and then this is going to go back up to your brain and tell you what you're hearing. So if you hear high-pitched sounds, then the bones have to vibrate what? Very, very fast. Low-pitched sounds, the vibrations are much slower and wider, and that's how you hear lower pitch sounds, okay? So this is all a system of vibrations, right? For hearing first. That's the #1 job for your ear, is to hear, okay? And then your sense of balance is going to be determined by the liquid inside of these bones, okay? So when you turn your head, essentially what's going to happen is when you turn your head, the liquid inside here is going to go up and down and around, and then keep going and flowing around. And there's a pattern to it, right? So that you know where your head is. And so how do you know where your head is? Because there's going to be dendrites in the inside. And so there's little bitty dendrites that will be between these simple QBT cells. And so they'll have little hair-like dendrites in the inside, right here. And so they can sense where the liquid is. And so when you turn your head this way, then more of the liquid's going to go this way. And these little hairs, the dendrites, can sense how much liquid's over here, so they know your head's going this way, to the left. All right, so that's your sense of balance. It all depends upon where your liquid is going in these various bones right there. All right, now with age, this area of dendrites, the spiral organ, it shrinks. It shrinks with age. And so then you don't have as many dendrites to pick up where your liquid is, and your sense of balance isn't as good. Plus, if you have a lot of calcium stones in here, they can get stuck. They can get stuck inside these tubes, inside your semicircular canals. And if you've got stones in here, then you're going to feel dizzy all the time, because a stone could be sitting right here on top of a bunch of dendrites, and that can be making you feel like you have vertigo. And that's what happens when you have vertigo, is you've got stones stuck on top of the little hairs, the dendrites, and that gives you the continual feeling of being like the room is swirling because they're stuck, right? All right, so that shrinks with age, and so your sense of balance becomes worse because a lot of times you don't have as much fluid, and this is especially true with girls. Girls, as you get older, after age 50, your estrogen goes down, and your fluids, every fluid in the body is going to be less in volume, and you're going to become drier in terms of your joints. You don't make as much synovial fluid. You don't make as much fluid inside your ear, the inner ear, and then you don't make as much fluid inside your eye, right? And so that dries out your eyes real quickly too. So that's more of a problem with estrogen. Guys don't have those kind of problems with testosterone. essentially. So that's sort of how the inner ear works, your sense of balance back here. And if you've ever heard of cochlear implants for people that have hearing disabilities, cochlear implants are a transmitter, an electrical transmitter, and they actually put it on this bone, and they'll actually glue it and secure it to this bone so that basically it can transmit electricity to the various areas of the inner ear. So it will work and pick up senses. It will pick up vibrations from the outer and the middle ear. And so those are called cochlear implants, right? And those really help. But the problem is at night, they're magnetic. They have to take them out. So if somebody has cochlear implants at night, they can't sleep with them in, and so they are totally deaf once they take those out. So they implant magnets in the inside on some of these bones, and then they put the magnet on the outside, and then it's right behind the ear, and that's called a cochlear implant that helps them hear rather well. It's amazing for people with really severe hearing problems. Okay, so that's your sense of hearing and balance.